Let's talk about you, and let's talk about your story, and I want you all really to think about some good questions, because these are going to be some great questions.
Yep.
How on earth did you end up doing what you're doing?
That's
something to start here.
Yeah. So I feel like AI has transformed radically over the course of especially the last couple of years. I started doing machine learning as an engineer back in 2009, so was doing very simplistic work with logistic regression, linear regression, decision trees, probably things that sound familiar to some of the folks in the audience, and was mostly doing it applied to kind of physical sciences projects. So machine learning is applied to the space sciences, or applied to subsurface geoscience, or applied to geophysics. And it was just kind of a means to an end, a means to analyze data and to make better predictions, derive insights from those complex data assets. Fast forward to around 2015, I think a lot of people started adopting deep learning methods, getting really excited about them. This was also the time when sort of the most exciting work around convolutional neural nets came out. You know, being able to detect between cats and dogs, or hot dog, not hot dog, if you remember the trope from Silicon Valley. And great open source projects started coming out, like TensorFlow, PyTorch, the JAX machine learning framework, which is now what Google uses, as well as many of the AI research labs. And then really just in the last couple of years, with the kind of rise of ChatGPT and these really powerful both image generation models, video generation models, as well as kind of complex multimodal models powered by transformers, you know, we've seen this dramatic shift. So for me personally, I started off kind of in geophysics, applied math, have always really loved computer science and programming, and then just kind of naturally fell into this really interesting wave. But it's felt like a different job, honestly, every year of that life cycle.
You got all that right?
Sorry. It's a lot.
It's a lot, right?
Yep.
I'm just thinking out loud, going, wow. You know, when you were younger in school, they probably, when they put people into groups, they probably want, I want Paige, I want Paige, I want Paige, I want Paige.
Well, I grew up in an extremely small town, so there weren't, like, if there was a group, there was like one group.
Yeah.
My hometown was about 1,300 people in rural Texas, and I think my graduating class was like 42. So it really was like single group.
So I'm gonna go back a little bit further now. So, like, you know, you've gone through school, and when you and I chatted earlier, you talked about, you know, you're a gamer and you're a fan.
Oh, heck yeah.
And clearly that probably had something to do with your journey moving forward.
Oh, absolutely.
So let's talk about that, because you mentioned some text-based adventures and things like that.
So when I was growing up, kind of my best toy was an Apple II that we had rescued from being thrown away. Somebody had donated it. Woohoo! Yep. Somebody had donated it to my school district's library, and people couldn't kind of figure out how to get it to work. And so a friend came over, helped us set it up. And I started programming text adventure games just because it was an interesting way to build kind of like choose your own adventure style things. It also came with a lot of software like Zork and kind of Moon Patrol and some of the Summer Olympic Games. But that really got me started in terms of programming. And then, you know, kind of formative games growing up as well, like the Myst series. I was also super fan of kind of more recently some indie games like Firewatch, Outer Wilds, walking simulators like What Remains of Edith Finch. Just these really beautiful stories that are very adventure driven. There was another one called Digital Love Story that was open sourced, but it was all about AI and how you like discover an AI that's within this old BBS system from the 80s. And so I feel like these adventure games are a really great way to inspire creativity and to help you feel kind of immersed in this world where you're constantly learning without having it feel like a challenge, and having learning being something that you're excited about, you know.
Was it the narrative and the creative stuff that led you into that, or was it more just the solving of the problem to give people a different journey?
That's a great question. I feel like for many of these games, so like Myst as an example, they're all kind of these exploratory puzzle-based adventure games. So in order to obtain the next piece of information or obtain the next piece of the story, you have to solve something challenging. And the motivation for solving this challenging thing is getting that next piece of the story. There was also a game that I played growing up called Grade Builder Algebra 1, which doesn't really sound like a game, but it was...
Talk to the branding people on that title.
Exactly, but it's so you're just kind of exploring around in this this cafe called Cafe Infinity, which also featured an artificial intelligence robot thing and a computer. But for each kind of successful module that you completed in algebra and geometry, you got another little piece of the story. And that was probably the best incentive that anybody could have ever made for me to complete like algebra and geometry.
It's kind of the original gamification.
Yeah.
Of taking something that could be seen as monotonous and daunting and making it fun.
Yeah.
Right. Badges.
Yeah, badges, and I think, you know, maybe we'll talk about this in a little bit, but I feel like right now, one of the challenges, I see it with my nieces and my nephews, is that these large language models, they're kind of being treated as answer engines. You know, you have a problem set, like a physics problem set or a math problem set, you copy and paste a question, you put it into, you know, ChatGPT or the Gemini app or whatever it is, you get a response back. But it's not really teaching you to kind of think about the system or think about this process of solving the problem. Because learning is hard. You know, it should be like a very thoughtful thing. But right now, you know, it's kind of losing that aspect. And so unless we can gamify the education process, you know, incentivize kids or ourselves to kind of, you know, solve this challenging thing and really, really learn before getting the next piece of the story, you know, we're going to end up in a really scary place, perhaps, for education.
Right.
Yeah.
You also talked about The Sims.
Oh, heck yeah, The Sims. Oh my gosh. Like the Sims, Sim Park, Sim Earth, Sim Ant, the Sims Deluxe Edition, SimCity 2000. Like I think I played every single one of the Sims that I could get my hands on, and they were also really, really great for helping help teach these concepts. Like Sim Park, as an example, if you added a whole bunch of bunnies, eventually like wolves showed up. And then you got to kind of reverse engineer, I think they're called the Runge-Kutta equations for predator-prey, by just monitoring the number of wolves and rabbits over time. It was amazing. And I think it taught a lot of really interesting insights too around systems thinking and around how to kind of navigate these complex spaces, which is honestly really, really useful for math, for physics, and also for things like machine learning and AI.
And you sneak in the learning again,
yes.
Right? You know, when I was talking with Marc-Alexis Cote yesterday, and he was talking about how his boss, the CEO of Ubi, they'd sit and have these terrifying meetings where he said, what did the gamer learn? What do people learn? Because they're doing Assassin's Creed, it's all historical, and he leaned in on that. And I think that the best games are the ones that teach you something without teaching you something.
Exactly, and it's so interesting too. The founder of DeepMind, Demis Hassabis, I'm not sure how many folks in the audience might have heard of DeepMind or heard of kind of the great research that they've been working on. But they're Alphabet's, Google's kind of predominant research lab. And Demis started his career as a game developer. He was developing, if anybody played Black and White, He was
Yeah.
developing the kind of AI and the intelligence for a couple of the characters in that. He also developed a simulation game, like one of the roller coaster simulation games.
Roller Coaster Tycoon?
Yeah, I don't know if it was that one, but it was
Or Theme Park or one of those, yeah.
And but it's definitely kind of baked into the DNA of AI researchers is games, kind of this exploratory, this curiosity aspect, and then a lot of the most interesting work done in the machine learning space was in reinforcement learning applied to the Atari games and to other kind of closed box systems.
And so I'm going to take another little step forward. So we talked about the games, talked about the stuff that you love to play and why you love to play it. And so you've been programming your own text games. You have been enjoying other people's games. All the stuff that came out from Maxis, et cetera. And then you think, okay, I want to go to school now, and I want to kind of dive into that. Tell me how that kind of happened.
Gotcha. So when I went to school. And this, in retrospect, it sounds very silly, but I guess kind of makes sense. Like when I was growing up, like I never knew any computer scientists. Like I never really knew any scientists at all. Like I didn't, everyone in my hometown was either a farmer or a teacher or an electrician or something of that nature. And so my expectation was like, all right, I'm going to go to college, and I am going to go to medical school. I'm going to be a computational neuroscientist. And then
the dream of every young girl growing up in Texas.
Well, it's what I wrote my admissions essay on it. I was just like, I really love computers. I like brains. I've heard that doctors are a thing. Like I will do that. And so I showed up and I was so excited. And I got told that's beautiful, but our cognitive neuroscience program is a PhD program. We have nothing for you in undergrad. So figure out something to do during undergrad as you're in theory, going to go get your MD, PhD. And so I ended up enrolling instead in something called cognitive science, which is, it's really fascinating. It's a combination of psychology and linguistics, computer science a little bit, but really kind of focused on kind of the more people aspects. And as part of this, I took a geophysics course as an elective. And when I was taking geophysics, as you're understanding the subsurface, you get this really complex data back. And you can't really drill super far down into the mantle. You kind of have to be clever about how you send in sound waves or extract out information using sound waves and build these complex images of the subsurface. And it's more or less the same techniques as you would use to capture fMRIs, so scans of the brain. You can't really drill down into things. You have to kind of be clever about how you derive insights. And so I was like, well, cool. I was trying to go more into the scans of the brain world, and I can't do that. So next best thing, scans of the subsurface. And so we'll see what the subsurface looks like. And they also said that I would get to play with computers. And I didn't know that computer science was actually a career, or that you could go into I assumed that there were some magical people off somewhere building these educational games, but of course not me. And so I ended up doing geophysics and kind of applied math. And then for grad school, I did earth science as well as computer science.
Okay, so now you got that under your belt.
Yep.
And so now the next step is starting to move more towards AI. Now I know there's probably a long period of time in between that.
Yep.
So how did you go from wanting to think about the brain and how to impact people's lives and look at neuroscience and whatnot, and then then finding hidden gold in water using math. How do you then take it to that next step?
Yeah. So. Then the nice thing is that geophysics, applied math, you're taking all of the courses that are required for building machine learning models. Right. It's linear algebra, it's differential equations, it's vector calculus, understanding all of those kind of base concepts. And the nice thing is if you learn those kind of Calc 1, Calc 2, Calc 3, linear algebra, vector calculus, Diffie, those things. No matter which field you go into, they'll all still be useful.
Right.
And a lot of the work that we were doing to understand earth science systems was actually just kind of machine learning techniques or fancy statistics, but with a different name, because the earth sciences for a long time kind of shied away from machine learning, and instead wanted to do something called geostatistics or kind of understanding those processes. But I kind of found out when machine learning and data science became the cool terms, like, oh, well, all the stuff that I've been doing is machine learning. And then the natural evolution of machine learning was deep learning. And so I just, instead of scikit-learn, I suddenly start using TensorFlow and PyTorch and those frameworks, and analyzing much more complex data sets, being able to kind of build models in a much more streamlined way, as opposed to attempting to do things like selecting specific features to put into the models. And now with generative models and with tools like Gemini, things that would have taken a month or so to build back in 2009, 2010, you can do super easily by just like uploading a CSV or uploading a data set and then saying, classify each one of these records into one of 5 things. So it's amazing how all of this has evolved, but it's basically still just trying to solve the same question. So like classify these data into different categories, or summarize these data sets in a certain way, or kind of extract out information and insights from these complex data sets and explain your reasoning.
Right, knowledge is power.
Yep.
Right?
This is true.
It solves all the problems. So then you're at Google.
Yes, this is true.
So then, when you first started with Google, was that exactly where you ended up? Was in AI, or did you start somewhere else?
Yeah, I started at Google back around 2017, 2018. Previously, I was at Chevron and Microsoft. And when I came to Google, it was to work on our machine learning frameworks. So the tools that people are using to build these models, to build these complex systems. Back then, Google was kind of moving from a framework that they had created called distbelief, which Google is a huge fan of puns, so am I, but a framework called distbelief to one called TensorFlow, which they open sourced in late 2015. I got really excited about that just because I think it was one of the first times where people outside of these larger research labs could really understand the process for building models, kind of all of these assets, some clever ways that you could use them for your personal projects. And so was Disbelief, TensorFlow, and then there was a project that was just getting started around that time called JAX. And JAX is now the new framework that Google is using. It's the framework that was used to build the Gemini models. Okay. So I was working as kind of a developer relations, developer experience engineer for those frameworks in particular. Did that for a while, and then moved to product, and was working on that for a bit before moving to GitHub for a year, and now back at Google.
Okay, cool.
Yeah.
So there's a lot of cool brand names around AI.
Yes.
And everyone's getting excited about it and not understanding it. So you've got Gemini, you've got Copilot, you've got Apple Intelligence that they're going to be talking about next week, and everyone's going to be, and then of course ChatGPT, and a whole bunch of other flavors, and people trying to sell you apps and different things to buy.
Yeah.
Tell me about so the world of AI. Does it all come from one place, or does it all come from proprietary places? Like if I go to ChatGPT, because you see things like powered by ChatGPT, powered by ChatGPT4. Maybe walk me through how does that system all work? Because I'm sure a lot of people may have the same question. Yeah,
and the naming is confusing. So if you feel overwhelmed, you are not alone, right? And I feel like there also needs to be a clear distinction between the models that get built, and then the user interfaces that people might leverage to interact with those models. Right. And there might be, just as in a game, you might have a physics engine powering some of the environments that you have in a game. That doesn't mean that the game itself is only the physics engine,
Right.
if that makes sense. Like you can use the physics engine to create differentiated experiences for your game. But if you're just relying on the physics engine itself, that's a pretty boring game.
Right.
So each company has kind of its own model, more or less following the same architecture, which is why you see pretty consistent experiences across Anthropic's Claude family of models, Google's Gemini family of models, OpenAI's GPT family of models. And really, the things that drive model performance is, well, how long was it trained? What data was used in order to train it? Because the model is only able to make predictions or to generate outputs based on the training data that it's seen. And then also, so we've talked about compute, talked about data, and then also some of the kind of techniques that you use to boost performance for certain aspects of the models. And most of those are very proprietary and kind of, but the Gemini models we've trained on a vast amount of information, as well as a lot of information and kind of proprietary data sets that we've created internally, such that the model is really good at things that you might not see as predominant in other aspects. So as an example, Gemini out of the box is able to generate bounding boxes across images. It has a longer context window. So I think publicly 2 million, and then we've sort of talked externally about how it can go up to 100 million tokens. And a token is just kind of a unit of information. When you hear 10 million tokens, just think like that's all of season 1 of Silicon Valley. Or it's every single email and every text message that you've ever sent in all your life. Or it's every textbook that you used in college. You're able to just say like, hey, Gemini, here's a whole bunch of stuff. Now please synthesize it all for me. Or here's a whole bunch of stuff. Now answer this question. Here's season 1 of Silicon Valley. Tell me everything that Erlich Bachman ate. And do it in JSON format. Like it's like those sorts of things without having to do any additional fine tuning or training. But those are the models. And so you have this model and think of it as kind of like an engine. And then the differentiated experiences are the apps that are built on top.
Right.
So ChatGPT, as an example, isn't a model, it's the app built on top. And it might have connections to data sources. It might have post-processing done on whatever the model's output might be. It might have kind of additional kind of reinforcement learning techniques to understand that you are a user that is a more technical user, so maybe they should give a more technical response. And it's the same for the Gemini app or AI Studio or any of the other differentiated experiences built powered by models. But it can be very tricky to decouple like what is a model capability versus what is the user experience that has been kind of defined by this application. And that's the more interesting piece, I think.
So when you talk about training, when you're training it, when someone types something in and they're very specific about their prompts, that just goes all into the machine? Is that considered training, and then it's all restored depending on which particular framework you've entered into?
So that's a really great question. So the model goes through this training process initially. It's called pre-training at most research labs, where you just have this big pile of data that you've kind of accumulated, pre-processed, and tried to get into a state such that you can run it across vast numbers of machines. And really, like the compute footprint for these models is massive. There have been kind of headlines about 100,000 H100s, 100,000 GPUs, but that's not the biggest training cluster, I don't think, in the world. And so massive amounts of resources required to train the model itself. Once you pre-train the model, then you go through these post-training techniques. And post-training is, I like to think in terms of analogies. So you can think of pre-training as kind of like if you have a kid, the kid is doing a lot of things as it goes through life. It's running, it's climbing trees, reading, learning to read, interacting with other humans, like all of this unstructured sort of learning that we don't even really think about as learning. It's just kind of like building this realm of experience. And then at some point, somebody says like, oh, well, you're going to have to take the SAT exam. And so here's a whole bunch of guides for taking the SAT exam. And hopefully, the things that you learned at school, the things that you learned through reading, whatever it is, will help you take this exam. But the reality is that you're probably going to have these guides to help align your perspective on, well, what kinds of questions are going to be asked. So the pre-training process, this initial model training, is kind of like that unstructured learning. And then this instruction tuning post-training phase is kind of like, well, here are the questions that people are going to ask you in the real world. It's like, or the questions that people are going to ask you on the SAT. Those instruction tuning pieces are kind of mission critical important because it kind of gets your model aligned with how it should be responding to user questions or responding to interactions. And then the actual SAT exam itself, you could consider that as like an eval. And that's why so many of the models you see their performance on the LSATs or the MCAT or like any of these other specialized exams, because you're trying to see how well the model can perform for those given tasks. So we've got this pre-training phase, this post-training phase, and then what you were just describing, the prompt that a user sends to the model. Most companies, if you're paying, they do not use that for training data.
Right.
Yeah, they just use it as kind of a prompt that the model can use to give better responses. Right. If you're using free tier for models, oftentimes those data do get incorporated back into training.
And and of course, there's so much more to AI than just going and doing prompts and whatnot. But
you can get pretty far with prompting.
But that's
though.
really key, isn't it? The
Yeah.
prompt that you type in, because of like I'm still going to go home and go, my name is Paige Bailey, and you're going to tell me how, as you would tell. And I know it won't do that, but it's very important that the quality of the prompt dictates the quality of the output.
Absolutely, and that's how it is right now. I envision that long term perhaps there will be something like prompt rewriting behind the scenes. So like you can give us a very simple question, and then the model kind of reframes it before it sends it to itself to answer. But you can also, and I encourage everyone to try this out, in aistudio.google.com, you can say, hey Gemini, I'm trying to use a large language model to develop a project plan for a new feature. Please write a prompt for me that would be that a large language model would need in order to do this very effectively using these criteria, and just like upload a PDF or something. And Gemini is able to generate a prompt which you can then give back to Gemini to do the task that you want to accomplish.
So it's almost like custom ordering what you're looking for before you submit it.
Yeah.
Right?
Yeah. It's really fascinating. Like I use Gemini to write prompts for Gemini pretty much every day.
Because one of my next questions is,
Yeah.
how often do you just, I imagine it's a part of your everyday life now.
Oh, heck yeah.
And
Yeah.
you probably use it all the time.
All the time, especially for work. Like I think I was showing off, and mostly I use AI Studio, so not the Gemini app, kind of FKA barred, but aistudio.google.com, because that's where all of the latest Gemini models are added. But I was looking at my kind of prompt history the other day, and literally it's like once every 2 hours, just kind of like, hey, generate this code for me, or hey, here's an older version of the code base, here's a newer version, please help me migrate this tutorial from one version to another. Or here are 500 pages worth of PDF documents, please extract out every single table and put it in CSV format. Or here is, another example is, here is a video of a user attempting to accomplish a task for 35 minutes in a very painful way. please generate a friction log for it in Markdown format with timestamps. And since it has the longer context window, it's able to synthesize, understand all of these very complex things very quickly.
Right.
Full code bases, full videos, all sorts of stuff.
I didn't realize you could upload a video.
Yeah,
So-
yeah.
What is he doing wrong?
Well, it's like videos, complex data assets, like CAD files, like all sorts of things. Yeah.
So I know one of the questions is probably burning in some of the people's minds right now is, what does this mean for my job? Right? It's kind of like a common fear thinking AI is going to replace me. AI is going to take away my what makes me awesome in my career. I don't believe that. I think that it's more of an enhancement. It's a tool. It's literally a tool.
Yep.
But what would you say to someone that says they're coming to take all our jobs?
Oh gosh, like I don't feel like I certainly don't feel like it's taking my job, and the reason that I say this, even though like 90% of the busy work, which was very painful busy work, got automated away with this model, I'm suddenly like 10x more productive. And it gives me so much more time to focus on the things that are really exciting about the work. Like the most interesting piece is, there are so many folks that, especially in creative things like game design or game creation, where you have to go through all of this bureaucracy or compliance requirements or just kind of boilerplate in order to do the thing that really brings you joy, right? And this just kind of means that you get to focus on the joy a lot more often, and the boilerplate just kind of gets automated away. And I don't know about y'all, but I will happily never have to spend more than 10 minutes writing a business requirement stock, or like have the basic formatting of it automatically generated, and then just kind of QC it. And be the executive just kind of making these changes, as opposed to spending a full day or 2 days attempting to do that. The other thing that makes me really excited is that I love games. They are so cool, and I've had ideas for games over the course of my life. And I'm really good at writing back-end code. But like I am terrible at front-end design. I can't make things pretty, and I also can't like generate audio or music or any of these things. And so, I would previously like try to build something and could get 85% of the way there, but not that final 15%. And being able to have models kind of help accelerate that process or guide me in the right direction is really powerful. I think there's, if anything, models, if you use them correctly, they're so much an accelerant to everything that you might do. And I don't think it's going to take anybody's job. It's just going to help people be more efficient and also help folks focus on the things that are the real value adds as opposed to just the process.
Right. More of an enabler than a taker-awayer.
Absolutely.
I had read somewhere that you had mentioned it, that a lot of Google code is written by AI.
Oh, heck yeah, yep.
Yeah, let's talk about that.
Yeah, so we've been applying AI to the full software development lifecycle. And Google's really cool for a lot of reasons. Like oftentimes it feels like living in the future to be able to work there. But it's been capturing telemetry on everything that our internal developers do for the last like 20, 25 years. So everything from writing code to looking at documentation to asking chat questions and getting responses back to like going and getting a snack from the micro kitchen and badging in. Like all of this stuff is kind of in these detailed software engineering event timelines. And what this means is that we can do really interesting things like code completion, code generation, et cetera, but also help with debugging, help with code review and automating and speeding up code review, help with kind of rewriting code to make it more performant or efficient and to use less resources, There's also, it can get really gnarly to write kind of lower level code that leverages GPUs or leverages TPUs or other accelerators. I had to write CUDA once in my life, and like that was probably too many times. And so the code generation for these more specialized topics, being able to kind of empower people who don't necessarily come from a Verilog background or whatever it might be to work with those kinds of hardware types is really powerful. But we've been applying AI to everything because as an engineer, you're spending perhaps 5 to 10% of your time actively coding on a good week. 90% of what you're doing exists outside of the IDE, and so if you can help kind of bring down the pain and the tedium of all of that time, it's really significant. I think right now, the last time I checked, 26% of all of the code at Google is generated by machine learning. And then for any given week, 50% of the code that gets checked in is kind of helped by machine learning in some way, whether it's code review, whether it's code generation, whether it's kind of smart paced features or whatever it might be.
I think that one of the things I'm looking forward to is how it's going to enable smaller game developers in particular, right?
Yes.
Of which I am one. And I think that, you've seen these mega companies, like EA, Microsoft, and Ubisoft and whatnot, and, they have just massive resources, massive amounts of people. But there's been an amazing resurgence of sort of like the small and medium-sized game. You talked about Edith Finch. I mean, I played that game, and I was fully satisfied at the end of that project, right? It's like, this is a great game. I enjoyed this game. And it doesn't have to be 90 hours of gameplay. It could be a smaller experience as long as it's a rewarding thing. And I think that a lot of the smaller indie studios are kind of like, wow, I can compete now with these kind of products. And it feels like AI can actually help them on their journey by taking some of those code reviews and the tediousness and the kind of low-lying GPU code, et cetera, out of the way.
Absolutely. It can help those people tell their stories without necessarily needing the massive hammer that these larger game studios kind of bring to the table.
Right.
I think the enabling smaller teams. There's been a lot of research done that smaller teams are much more efficient. There are fewer communication bottlenecks. You can build this kind of auteur concept of like a single person or a few people can tell a really well-crafted, very honed story in a way that these more massive teams, might struggle to.
Right.
That's something that AI can certainly enable. And I agree. I loved that game so much. Interestingly, the game studio Annapurna Interactive, Annapurna, their film division, also produced the movie Her. If folks have seen it. So Stray, What Remains of Edith Finch, lots of great titles coming from that studio.
And I like those games because I remember those games.
Yes.
There's games that have had an impact on me because there was a great story and the way that was realized was amazing. And I've forgotten lots of big games that I've played because it's like, here's another one, and you become kind of like entertainment blind when you're playing something because you just expect it to be the same thing. And these little guys that come along and make so amazing.
Interestingly as well, there was, one of the first experiments that I did with the latest Gemini models when they first came out is I took the old Zork code base and I put it into Gemini's context window, so you can just kind of like send it in. And I asked Gemini, just kind of in chat format, like, play this game with me. And it started off with kind of, you're in front of a White House picket fence, that sort of thing. And we were progressing kind of step by step through the gameplay. If folks played it, you had to be very explicit with directions, so like say specific words to move to the next stage of the game. But with these large language models, you could be a little bit more flexible. And it also got hyper-personalized towards the experience that I wanted for that game. So I asked to describe the scenery around me. It was able to give really interesting things that weren't included in the code base, but just kind of descriptions of the scenery around me. I asked to be turned into a GRU, and for a portion of the game, it just like navigated me through the game state as a GRU instead of as the character that I was playing. I went to look at a trunk full of books, and I said, tell me the titles of the books. That was never included as part of the code base, but it was something that the model was able to keep as part of its state in the context window. And I asked it to teach me about one of the books that it had said was existing in this trunk. So you can create these hyper-personalized and very memorable game experiences for each individual user,
Right.
As opposed to just having one story that gets sent out to every single person.
Right.
And the nice thing about that Zork experience too was that I could entertain these little side quests. Like I could ask about books in the trunk, or I could ask to do this other thing, but it would eventually navigate me to that final destination.
Right.
And so for each user, like if you talk to a friend about it, you might say like, oh wow, could you believe that game? Like, I couldn't believe when I got to the final state. So you would have this shared experience, but you would also have these other things to talk about. And every time you play the game, you get a different experience.
And it was funny. I was talking about this very thing with one of my colleagues about how this is going to make NPCs in games not suck.
Yeah. Heck
Right? Because
yeah.
they're just going to kind of dance around and going, quest, and then you'll talk to them. They'll say the same thing every single time.
Yeah.
But that is amazing to me. I'm going to get from here to here, but I can choose how I want to get there, and the experience is going to be different.
Yeah.
And when you play a game and you're playing it and you have those moments where you see something glinting off in the distance. By design, everyone expects you to see the glint in the distance, and you find it, and for a very small moment of time, you feel like, I'm the only person that found this.
Yeah.
I am so good at this game.
Yeah.
And now, you really can actually have such an incredibly different experience based on all this stuff flooding into the world of NPCs.
Absolutely. And it's that I really do feel like, to your point about what remains of Edith Finch, like I felt a really profound emotional connection to that game. I think partially by design, but then also because each piece of the story kind of resonated in a different way. Like how magical would it be to be able to create games as a designer, as kind of like an engineer, where you can introduce like these super emotional, kind of hyper-personalized journeys for people, that each time they pick up the game, each point of their life, they find something new and something exciting.
I think it's going to change the whole game review process too. I think people are going to start reviewing games in the way that they always review games, and I think that someone's going to go, "Oh my God, this game touched me in a way that I've never played a game before," and it's because of this interesting stuff.
Yeah.
I also think that it's going to, people talk about quality assurance and making sure that a game is properly done and the quality is there and the experience is great. And I think there's going to be a really interesting role between the people that test the product to make sure this is a satisfying experience, as opposed to trying to recreate something that can only be created when you take the console and you put it underwater and you throw it in the air and then push X 10 times. I think that perhaps the AI systems are going to be able to go, okay, you're trying to recreate this, we're going to find every way to try and do it to enable that to be fixed.
Yeah, absolutely. Like you can deploy agents to kind of go and find if you click this button 10 times, then suddenly something explodes, which is kind of, I would imagine that would be a little bit more tedious than the kind of testing where you're like, I'm navigating, but I don't understand why I should go in this direction. Or I'm navigating, but it's really, really hard for me to understand which piece I should go to. And the agents bit, like managing a fleet of agents to be your test fleet for each one of these games, is very powerful. Whereas you, as a very human person experiencing it, can give that much more insightful feedback about the gameplay experience.
And and flipping these toggles too. There's a lot of very intense simulation games where you're in control of everything. You have to make all the decisions, but you spend so much time trying to figure out which drop-down menu is going to do this, and do I want to assign this to that, and it makes the game suck
Yeah.
because you just want to get to the fun.
Exactly.
And there's all this tediousness, and perhaps there are ways that said, hello, AIs over here can make your job a little easier on this journey.
Yeah, and sort of take away the confusion of these really, really complex UIs. Like Photoshop, as an example, Photoshop is a really, really powerful tool, but there are all of these knobs and dials. Like I would never be able to figure it out just by sitting with it for a few minutes. And so if you can sort of gradually decrease complexity or increase complexity where it makes sense for the gameplay UI state, I think that would also be really, really interesting for the experience.
I love things that streamline things. I love things that make me feel awesome. My colleague Jeff Coates is in the audience. He's a creative director and studio I work with, and I don't have to send him images to get him to remove the background anymore, because I can do that online with a system that knows what I want. Then it's like I don't have to bother him with that tediousness. I can just do this, right? And that's kind of an example of AI making my life way easier. So, wow, that went fast, didn't it? Man, we wanted to make sure we had some time for questions. And the yellow light is on, and that means it's question time. And
excellent.
So I'm sure we have some questions, and so I'm just waiting for my fabulous Mike Gallia here. This microphone makes almost as much noise as my microphone was making during the show because I was banging against my vest. This is a throwable microphone. Oh, cool. And you speak into this part. And if you have a question, I can throw it out to you, and then you can speak into it. I'll do the lob to you in a minute, and you can ask the question. And then when you're done, someone else can put up their hand, and they can ask a question. So
awesome.
I'm gonna do an underhanded lob here, so I can get some arc. And there we go. First question.
May not be working. Try this one.
It was a good.
Oh man! After all that.
Cool. Yeah, I won't throw this one back. Thank you. Well, great. Thank you so much for your insight, and thank you for an excellent interview. I kind of wanted to start the Q&A by ripping the Band-Aid off of a tougher question. And because it is such an expansive and potentially divisive thing, I want to draw as small a box around it as I can.
Yep.
Being an art services provider, I'm primarily concerned with generative imaging, right? And so many of my employees in our studio's name appear by name in various training data sets. And now that those training data sets have been implemented into models and applications that are pulling from those models, and they're being commercialized to create monetized products. What, if anything, do you think the copyright holders and originators of training data are owed in the process of publishing AI-derived commercial products?
Yeah. So Google has produced a couple of image generation, video generation models. One is called Imagine and one is called VO. But the training data sets for both of those models were kind of specially curated to be only kind of publicly visible, like allowed non-copyrighted images and video. I can't speak, of course, to other model service providers. And I think Google has also been, we've been exploring a lot of different applications for our Gemini models, which are all kind of text generation, code generation, but being very kind of thoughtful and wanting to partner directly with creators for the image generation and the video pieces. And I think that's the only way that they can truly be successful, honestly. I don't, and of course, I don't speak for Google, but I do feel like in order for models and creators to be able to truly make meaningful projects, it's going to need to be a collaboration. And of course, like model service providers cannot be training on copyrighted images unless those are licensed. But I don't have an easy answer other than at Google we've been very thoughtful about how to release these specific kinds of models and doing it in a way that is in direct relationship, not just with image creators, video creators, but also with musicians, in order to make sure that everyone feels like they have ownership and kind of full creative control over whatever gets produced.
Thank you.
Okay. Next question.
Yeah, why does ChatGPT keep getting my math problems wrong? It's been erroneous on several occasions, and when I asked it to check its math, it did eventually get there, and it also did apologize, so that was nice.
Yeah. Awesome. So I of course don't work for OpenAI, but some reasons why that might happen. Models are they're trained on a vast quantity of data, but they also don't have kind of something called tools use innately baked into the model itself. So like if you ask Gemini a math question, it doesn't like go and pull out a calculator to solve it unless you explicitly kind of define that function calling or that tools use capability. And it's the same for the GPT models. So if I was going to be, if I was imagining myself as an engineer attempting to debug why this was happening, I would say that the model is generating outputs, and it's just based on the things that it's seen in training data. It's probably never seen that exact question, so it doesn't know the exact answer. It's just making an educated guess. And a way that you could solve it would be to say, all right, model, you have a bunch of tools or other models at your disposal, including a calculator, including the ability to generate code to solve math equations, including the ability to run that code to like check to see if it's actually correct. And then that's kind of a mechanism to build better outputs. If you ask, just as kind of an aside, if you go to the Gemini app or to AI Studio and turn on code execution, it's really fascinating that if you ask a math question, so like generate a Fibonacci sequence or something of that nature, what gets kicked off is behind the scenes, Gemini realizes like, all right, that's a math question. I'm not super good at math out of the box because I've just seen a whole bunch of information online. So what I'm going to do behind the scenes is write some code to try to solve that math equation. I'll generate an output, and then I'll give you that output back as a response. So that's why. Like the model itself has just been trained on a vast amount of data, probably never seen that question before, so it doesn't know the exact answer. Pardon me. But it can generate code to help solve the equation itself if you set up tools use and function calling.
Right. Next question.
Hi, I'm Jeff Coates. I'm the guy that Joe is putting out of work with his Photoshop.
Oh, cool.
Yeah. There's a lot of talk about the prompts, like the way that we prompt AI to get our answers and stuff. And I've heard a lot lately about how that's changing. There was a very brief window where people were talking about prompt engineers, that type of thing.
Yep.
And I've heard that that's going to be obviously going away. Where do you see the future of that kind of interaction with AI?
Yeah, so this is related to the kind of prompt rewriting that I was mentioning that is increasingly happening behind the scenes. If you kind of go to Gemini and ask it to write a prompt for you based on kind of a short one-liner of the thing that you're trying to accomplish, it's pretty good at doing that already. And so it's just kind of an extra step baked into the UI layer to say like, all right, this was the thing that the user asked for. Now Gemini, please rewrite it. Okay, that thing that you rewrote, now do that. As opposed to expecting the user to take all of that ownership. I do think that just as for humans, it's really beneficial to be able to think clearly and articulate, the kinds of things that you would like to see. The same as if you were working at a team and you wanted to contract out some of the work and detailed very specific project requirements. That's a useful thing. But I think that over time, what we're going to see is that the model does a lot of this prompt rewriting behind the scenes before it generates back out that output. In the interim, though, I always find that I get much more effective model responses by having more detailed and thoughtful prompts. Just as if I was going to give an intern a project, the intern would probably do a more powerful job or have better outputs if I give very specific, detailed instructions.
Thank you.
Thank you.
Yeah.
Do we have another question for Paige? Oh, we do, in the back. And there's one up here afterwards, Galia.
Thank you for a great talk so far. I had a quick question about maybe a potential forecast for the next few years for our industry. So, in your opinion, do you see game developers utilizing perhaps middleware, like a few game development-focused middleware applications primarily? Or do you see successful developers setting up their own machine learning teams to interface with models directly or create their own models?
So just to give a little bit of insight into what seems to be happening across the industry today, and I feel really fortunate in the sense that working with the Gemini API team, you can see a broad spectrum of use cases where people are sort of leveraging the model to do interesting things. The most adopted tooling and the thing that kind of moves the needle the most, just as for honestly cloud service providers, you have the API itself, but the thing that actually drives user adoption is the user experience that you build around that API. So tooling like Cursor or Copilot, or kind of the Gemini integrations into Docs or into Sheets or into any of these experiences, that's what is really, really important. And not so much the kind of one-on-one interaction with the model itself. Like if you're an engineer and you're trying to write code, it's really frustrating to pull up something like AI Studio or ChatGPT off to the side that breaks you from your flow in the IDE and then goes back. So I think there are going to be like the most adopted and kind of beloved experiences are going to be those verticals built, using one of the large language models. So, using Claude or using Gemini or using one of the GPT-4 models, but that are hyper-personalized and specialized in creating this great user experience. We can see parallels to this for AWS and for GCP and for Azure. There are all of these companies that build kind of layers on top that they get heavily adopted, like Snowflake or Databricks or Vercel or any of those kind of like things that make cloud infrastructure something that a user doesn't really even have to think about. And I think that if anything, I'm super bullish about that vertical layer piece. Much more bullish than I was about startups that might be trying to build yet another foundation model. Because the personalized user experiences are what are really powerful.
Great.
I don't know if that made sense, but yeah.
That was great insight. Thank you.
Yeah.
We have time, I think, for one more, and there was someone up front here, or? Oh, that's someone right up here. She's been waiting patiently.
Mm-hmm. Sorry.
Okay.
Sorry, she's giving me stink eye if I don't do this.
Hello. We work at Maxis. Thank
cool.
you for the shout out on The Sims.
Oh, cool.
We really
Okay.
appreciate it, and
Yeah.
hearing your perspective is great.
Yep.
I have go ahead.
Oh, I was just going to say, like every AI researcher I have ever met, we've all been obsessed with The Sims.
Yeah.
Like
I love.
far and away.
Yeah. And I actually have a background in psychology and cognitive psychology.
Oh, cool.
So this question is going to be a little bit more light and fun.
Yep.
What are your thoughts on GPT boyfriends, girlfriends,
Oh my gosh.
therapists?
Oh my gosh. So.
Let's talk about Dan.
Oh gosh. So I again, personal thoughts, not speaking on behalf of Google. I have not sort of dived deep into those realms. I think that there's a risk that people kind of sort of spend more time building relationships with digital assistants than they do with kind of interacting with humans. And and sort of building in-person relationships. If anything, I feel like in-person relationships and in-person experiences are going to become even more powerful going forward, especially as more and more content gets produced for video and images. The kind of cohesiveness and the real community that you feel in an in-person event is something that can't really be replaced. For these AI boyfriends and girlfriends and therapists, I would love to see them becoming more tools that help people learn how to have more healthy relationships with other humans, and that kind of guide them into like, hey Paige, you haven't seen your friend in like 3 weeks. How about I schedule a hike for you two over the weekend? Or you haven't reached out to this person in a couple of months. Like, how about I schedule coffee for you? I think those things would be much more meaningful and much more sticky as just user experiences. And coincidentally, have not really seen any startups formed around those things. Maybe because it's harder to sort of have that intuition and the emotional perspective to nurture in-person relationships.
Awesome.
Yeah.
Great. Paige Bailey.
Oh,
How great was that?
thank you.
Got your name right, too.
Oh, yeah. Good job. Thank you. This is fun.